Okay. Thank you very much for this warm welcome. So without further ado, we'll just go straight into the business of the day. So today I'm going to be talking about Python for data analysis. So we're going to have a practical approach to learning Python. I know some of you might be like, what exactly is Python? What is this? And what can I do with this? Don't worry about it. We're just going to give you some information to get you started. So who is this workshop for? We already went through that in the beginning, but our focus in this session is going to be on the key Python libraries. We're going to do a little bit of a hands-on experience and also practical example of what it means to actually do data analysis or data science. So what would you need for this? You're going to need a computer terminal. I'm not sure how many of you are connected with a terminal, but we're going to need that. And then we're going to use a notebook. A notebook is an environment where you have all your data science packages, and you can use that to perform data science on the go. So we're going to use Google Colab as our online notebook, but I'm also going to give you a home assignment where you need to download Jupyter Notebook, which is de facto for data science. Okay, so this is our agenda for today. I'm just going to do a brief introduction about Python, about data analysis, and about Jupyter Notebooks. And then we'll go straight on and do and learn about the syntax and data types of Python. And just like I said before, we'll do a bit of data manipulation. And also we'll be learning about libraries. Example of the libraries we're going to learn today is Pandas. Pandas is a very useful library for data manipulation. Also, we're going to do learn about data visualization. If all of these terminologies are sounding really foreign to you, don't worry about that. We're going to give you some information to get you started. So let's go on. First of all, what is data analysis and why is it important? So data analysis can be defined as a scientific method of analyzing. Okay, you don't want that word. A method that you can use to get information from data. We already talked about data. What is data? Data is everywhere. Everything we do, it can be termed data. Okay, so when you're performing an operation on your phone, right? Google, for example, is taking note of everything you're doing. So they're grabbing all your information, and that is called data. Okay, so with that information, they're going to perform lots of scientific methods to arrive at something useful that is eventually going to help the company to achieve something or to solve a problem. So that's exactly what data analysis and data science does. That's what artificial intelligence is all about. It's about deriving information from a group of, would I say, non-uniform or non-organized information. You're going to process them and use them to solve problems. So that's what data analysis is all about. So for you to be good at data analysis and data science, what do you need to do? You need to develop an analytical mindset. What exactly does that mean? So for you to be analytical means you're deep rooted. Okay, you're able to ask deep questions. So if someone says something to you, you're not just going to take it on a superficial level. You're going to want to know why, right? So when you find out the first why, you want to know again, why is that why? And then thirdly, why was the why that happened and why did that happen? I mean, if that doesn't make sense, I'm just trying to explain to you how deep you should be in your thinking if you must do data science. So you need to develop a problem-solving mindset so you're not afraid to dive into something that you don't know, right? Because you're curious, you want to know, you want to identify the root cause of a problem. So why did this happen? Right. So what should we have done for to stop that from happening, and what are we going to do in the future so that this doesn't happen again. So that's what data science is all about. That's what data analysis, and that's what artificial intelligence is all about. So what exactly is Python? So Python is a medium of expression. It's a language that data understands. So data, as we said before, is all of that information which is not organized, right? So how do you get information from it? How do you use it? It speaks a language called Python. So data speaks to you through a medium called Python. And how do you speak back to data? You speak back to data using Python as well. So you see why Python is very important in data science. So it's very important if you want to start a career in data science, you need to learn Python. And it's very easy. Why has it been chosen, or why is it preferred among data professionals? Because it's very easy to learn. It's versatile. It's very popular. There's a whole lot of ongoing support for data for Python. It's open source. You must have been hearing about open source. What exactly does that mean? It means that everyone is empowered to contribute to the development of this language. Okay, how do you contribute? For example, someone is working with Python and they have a problem, they experience a problem, and they're like, right, so I've seen this problem, what can I do about it? You just log onto your computer and then you log into Python collaboration suite, for example, and say, right, so I've got this challenge. Is there anyone out there to help me? And then in the next 2 seconds, someone is responding to you, yes, I can help you. What is the problem? So it's amazing, right, that you're able to get this online support and collaboration using Python. So that's why it's the most preferred among every other languages for data science. Okay, so that's about why Python is chosen by or preferred by data professionals. And then next, we're going to talk about the libraries for data manipulation. So I spoke to you earlier about libraries. So libraries are packages or environment that has already been developed for you that can help you to perform your analysis. So for example, you must have been hearing or seeing this called Pandas, right? Pandas is a library for data manipulation. What does it mean to manipulate data? Just like you manipulate things in the natural, right? You move things about, you run your hands through things, you change the shape, you resize things, you cut things, into a shape that fits what you want to achieve. So that's exactly what Pandas does for data science, right? So Pandas is one of the tools for that. And then we have another one called NumPy. NumPy is used for mathematical operations. So for example, I forgot to mention that. So what does Python actually do? Pandas presents your data to be in form of a data frame. What is a data frame? A data frame is just like a table, right? A table has got a top and it's got legs, right? So that's exactly how you should picture a data frame. So a data frame gives you your data in a format that has got a top, which is called the rows, and then it's got legs like a table, and that legs is called columns. All right, so you're able to see or visualize your data in the form of rows and columns. So that's exactly what a data frame is. And then why is it important to see your data in this format? You're able to locate your data points at every specific point where your data is. For example, if your data was in the first row and first column, right, you can easily call that location or that position, and then you have access to your data. So NumPy is an example of a library that can help you to visualize or manipulate data and perform operations on them. And then finally, we're going to have a look. I mean, there are lots of libraries, but just to get you started, I chose these 3 libraries that is going to help you to get your insights, very quickly. So Matplotlib and Seaborn are examples of tools that can help you to visualize your data. So why is data science really very cool? It's very cool because you can have all of this information that doesn't make sense, and then you present them in a form of visualizations, charts, for example, pie charts, for example, from any other kind of chart like horizontal bar chart, vertical bar chart, or or different. There are lots of sophisticated charts which you can easily look at and be able to understand. For example, trends, right? Are sales going up or down, right? Or do we need to put in more resources in this product or in that product? So you can see that bit of information very quickly when you look at them as charts. So that's why Matplotlib and Seaborn libraries have been developed for us to help us to see this quickly. Okay, so without further ado, I'm just going to carry on with that and give you a bit of more insight about data science and data analysis. So what exactly can you achieve with data science, right? So first of all, you've got information in form of, you've got data, for example, in form of like things that you have downloaded from an application or from a software or from a place, right? Or even your day-to-day transactions that you record in, for example, an Excel sheet, right? You now download this information. So what exactly can you do? What analysis can you perform on this, right? The first one I'm going to talk about is the descriptive analysis. So it looks at what you already have. So it looks at historical data, because for you to download information, it's already outdated, right? It's not happening on the go. It's not live stream, right? It's something that happened before now, right? So you can use descriptive analytics to describe what went on. So let's use a practical example. For example, you have a sales data, right? So you have a website, right? And then you sell some products on your website. And then when you finish all of your transactions in a year, okay, for example, a year, so that is the range or the age of your data set. So when you get this sales data, right, you want to perform descriptive analytics on the data sets. You want to find out what happened, what is the history, what really went on, right? What regions. Sorry, did someone stop me? Do I need to stop?
No, Bella, go
I
ahead.
guess she's muted. Yeah.
Okay. Okay, sorry about that. So I'm just going to carry on. So it's going to perform descriptive analytics on your data. So what happened? What did we do well? How many, this, for example, you have 4 regions, north, south, east, west. You want to know what region was the best performing region. Okay, so from your descriptive analytics, you can find that out. You want to know what region had the highest sales. You want to use descriptive analytics to find out. So all of that questions of what went on, you can find that out using descriptive analytics. So the next stage is diagnostic. So just like you want to go to a hospital and you want a doctor to diagnose what is going on with you, what is going on. I don't understand how I'm feeling today. I want to go to a doctor to say, right, so I feel this, I feel that. So that's diagnosis. So in data science, we also do that. So we want to know what actually happened. Why did it happen? So the sales went up by 20%. Why? Okay, what did we do wrong? I mean, what did we do right? Did we perform some marketing campaigns? For example, did we put out some ads? Did we do some promotion? Did we reduce prices? Did we do some sales? Right? So why did it happen? So we want to take a record of those things that we did right that led us to that positive change. Right? So on the contrary, we want to know what didn't go well, right? And want to know what contributed to that. So that's all about diagnosis, and we do that in data science. And the next step is the predictive analytics. So, right, it talks about what is going to happen. You're able to predict. This is very important and it's very powerful, because here we introduce modeling. We introduce machine learning, for example, is able to give us models like a linear regression model, which we can use to predict. So what exactly is prediction, right? We want to say, so for sales to go up by a certain percent, right, in the next 2 years, what do we need to do? Okay, so we're going to predict our input that can help us to get a certain output. All right, so that's a prediction. Then prescriptive, right? So we're thinking about our strategies for our company. All right, we need to when we're developing strategies, we have goals, we have visions, we have things that we want to happen in the next. When Herbert talked about personal branding, we saw where she said, right, in 10 years time, where do I want to be? Right, so you're going to use a prescription to say, for me to be where I actually want to be in 10 years, what do I need to do? Right. So that's what prescriptive analytics is all about. And we also use a powerful artificial intelligence and neural networks to be able to get to that stage. So that's a bit about how powerful data science is and the tools that we can use to get there. So going on to the actual hands-on experience of Python for data analysis, I'm going to talk about the syntax of Python. Why did I say it was powerful? Because it's very close to human language. So for example, you see something like this: 2 is equal to 1 plus 1. Right, that looks close to what we know, because normally we would say 1 plus 1 is equal to 2. But here in Python, we've put the results first before the operation. So that makes it very easy to understand. You can easily relate to it because it's close to what you've been doing before. So that's an example of a syntax in Python. Also, very importantly, we'll talk about variables. What are variables? They are things that we use to store the results of any operation or any values that we have. So I'm going to show you that in a bit, but just to let you know, it's a container. So for example, you want to put something in the refrigerator. You don't just put it, for example, you have a piece of like some food or some soup, right? You cannot just put soup in a refrigerator. You have to put it in a container. So that's what variables are in Python. They're used to store the results of an operation which you have performed. So it's very important. And then we're talking about data types. So how exactly can you use Python, right? It's like we said before, it's a language. And how do you use data types in a language? Data types is just like what is acceptable, right, in this language. So I'll just give a direct example of a data type: an integer. An integer is a number, like a 2, like 1, like 3. It's a whole number, right? So Python supports integers. Then we're going to look at floating points. I mean, it's very similar to what we do in the natural world, but just the names are a bit different. But if you see the numbers, you would know what they mean. So floating points are just numbers that have decimal points. So for example, 3.14 is a floating point. So that's a type of a data that we use in Python. And then the string data type is like what we know in the real life. We want to type a name, you want to type a food, you want to type a place. Those are strings. It's able to take characters. So your normal characters like A, B, C, D, you're going to put them in a string format. Python can understand that. So we'll go next to the basic operations. Just like I said earlier, these are really close to what we do in the natural world. We do addition, we do subtraction, multiplication, division, right? And then this might be a bit new to you. Modulus is a different kind of operation that gives you the remainder. So in normal terms, you divide, you want to do 4 divided by 3. Okay, so you're going to have a remainder. So in Python, you use a modulus operator to return to you the remainder of that operation. So because it's very important, sometimes you don't need to throw the remainder away, you just need that one. So that's what modulus does. And then exponentiation is just when you say something is raised to power. So you want to say 2 times 2 times 2. So you use exponentiation to do that. So that's a bit about that. So I can't wait to take you to the code where you can see Python actually working, in action. So next, we're going to go straight to basic data manipulation. But before that, I want to find out, is there anyone who's able to join in the practical session? Is anyone able to log into Google Colab? Because I want you to to try your hands. Okay, great. So I'm just going to send you the link so that you can, okay, beautiful, beautiful. So I've got a couple of things that I would like you to do after this class called a home assignment. You're going to try to install Anaconda, just to demystify this concept for you so that when you see them again, you're not like, right, I've never seen this. You know that, right, I've seen this and I can actually deal with it. So that's the aim of this this exposure. So you're going to install Anaconda on your workstations using a Jupyter notebook. So I've got some installation guides, which I'm going to share with you. After now, I'm going to share to the participants. I've also got Introduction to Jupyter Notebook, which is going to help you to actually start getting your hands on the practical task. And then I'm going to give you some other notes about data structures, and then a few other notes here and there. Okay, so for us to get started, I'm going to send you the link of a...
Just to interrupt you, Bella.
Okay.
You have 10 minutes of which you know how to still utilize the span.
Okay, great. Thanks for that.
Okay, thank you.
Okay, so in 10 minutes, we're going to just have a look at where we can practice Python. And the one that is very easy for us to get to right now is the Google Colab. So I'm going to just share you the link to Google Colab so that you can get your hands into it. Okay. Okay, so I'm just going to type that in the chat and have everyone just click on it. I'm going to take you straight to Google Colab, and then we'll just have a quick look at what you can do there. So let me see your hands up or thumbs up if you're already in Google Colab. Okay, you're on Google Colab, great. So we're just going to work through it together just to let you know what you can do here. Okay, so when you open Google Colab, you're going to see that screen first. That's the first screen that you see. So just like I said to you, it's a notebook. And what is a notebook is an environment that is already prepared for you to be able to do your data science work. All right, so what you want to do is to click on the new notebook. Okay, so it's going to open an entirely new environment for you. Right? So that's a notebook. This is where you can do all of your data science work without having to install anything, right? It's supported by Google. It's practical. It's on the go. You don't have to do much, right? So when you come here, this is environment, and this bars here, all of these are just to help you to understand what you can do here. But what is mostly important here, this cell, this is called a cell. All right, it's called a code cell, right? So this is where you type your codes. So like I said to you, 1 plus 1. Okay, 1 plus 2.
Excuse Bella.
Yes.
Bella.
Yes.
Excuse us. The other tab is not visible. We're still on the hands-on project here tab.
Oh,
Kindly.
okay. Okay, great.
Yeah, you
I'm just gonna
you can share the entire screen.
stop sharing this. No, I think I'd rather just share the right one. Okay. So I'm going to share that one, specifically Google Colab. Okay, here we are now in Google Colab. Like I said to you before, is everyone in Google Colab right now? So maybe you can
now
it's
your screen. Yeah.
Okay, you can code along with me. When you're there, just type in. I'm just going to show you that you can do data science without knowing that you're doing data science, okay? So this is called a code cell. So this is the cell where you type in your codes. So like we said before, it's close to human language. You want to do mathematical operations, for example, you want to do 2 plus 3, okay? You've just typed in a code. This is a code, right? So you'll be surprised. It's not as difficult as you think, right? So when you type 2 plus 3, you want to run. So when you click on this play button, it's a run, right? So you want to run the cell to display to you the results. So that's exactly what we're going to do. Now you've seen your answer, right? Isn't it amazing that in a minute I mean, this is because it's a simple operation, but if you had a very complex operation, the same way You just type it in here and then you click run and you've got it. Okay, so that's just introducing you to Google Colab. You can use this for different things. So I'm going to stop sharing and go straight to the presentation that I actually made for us to walk through. We haven't got much time just for you to see what we could actually achieve. I'll stop sharing and then I'll share that one. So it's a hands-on data science project. Okay, so now before you start, you have to first determine what exactly am I trying to achieve. So that's the first. So we're going to have a look at data science data analysis pipeline. Okay, Farhana, how much time have I got? Farhana?
You've got around 6 minutes to time.
Okay, can you help to answer the questions? Monica is having a problem with the run. So you just type it and then click on run. And someone could share the Google Colab to them, please. So I can quickly show this before my time goes off. All right, so this is a data analysis pipeline. What is a pipeline? A pipeline, just like if you can visualize a pipe, right? It's this round tube with two, it's got an opening and it's got an exit, right? And then you want to go through it to be able to come out at the other end. So that's what exactly a pipeline is in analysis. So it's a set of steps that you need to go through to help you to achieve your results, quickly and in a very structured format, right? So these are the pipelines that you need to use to be able to achieve a data analysis project, for example. Okay, so first of all, you have to define your objective and the questions that you're trying to answer. So if you were a data science professional in a company, for example, the business could come with a series of questions, right? They've got challenges, they've got things they want answers to. So they're going to just chuck this at your table, right? So we need to answer all of these questions. These are the challenges we have, and it's your job to use data to solve that challenge. So that is the first step. Define your objectives and define the questions that you want to answer. Okay, so that's where your analytical mindset comes in. That's where your problem solving mindset comes in. That's where your questioning mindset, like you want to find out why and why and why again. So when you've got all this written down in a very structured way, then you can start to perform your analysis. Of course, you need to have your data set. So the data set is your is the raw data that you've got, which you want to dive deep into to help you to solve these problems. So what do you do first? When you've got the data set, you want to import your libraries. Just like I said to you, you're going to import the libraries, pandas. We have this acronym that we use as PD. And the next one, NumPy as NP. So I'm going to send this to the chat so that I have everyone just type this into their cells. And then let's see what you get in your outcome. Okay, can everyone please copy and paste this in your code cell and run? And then let me know if you've done it so that we can carry on. Okay, great. So now you've imported the libraries that you're going to use to perform your first data science project or to solve your first data science problem. So I forgot to add also the problem, the data set that we're going to work with right now is data set on housing, right? So it's a housing data set. It's the houses in California. So we want to have a look at these houses and find out what we can, where is the best place to what is it called? You want to invest in housing. For example, in California, you want to know, where should I invest? What neighborhood should I invest? What is the mean price or the average price of houses in this location? So we just want to know, what is the data saying to us, right? So that's what we're going to deep dive into in this very short, maybe 2 minutes, but let's see. So when you've imported your libraries, the next thing you should do, you need to acquire your data. What does that mean? You need to import your data sets. Okay, so in this Google Colab also, I didn't tell you, you have some data sets that already comes with Google Colab. Okay, so we might not have time to show you how this is, but if you click on that, if you can see that file, can you see that file button on the extreme left? It's the bottommost icon. If you click on it, and then you're gonna see sample data. So if you open it, you're gonna see some inbuilt data set already by Google. So you want to click on the California housing test. All right. I might not have time to show you how to import that, but I'm just going to show you the code so that when you type that code, I mean, it's not very difficult. You just want to copy the path where this data set is. You just want to copy it. Okay. You click on copy path. When you click that, then you get this code that I have here. But just to save time, I'm just going to copy that and show you. So what you're doing actually is called data acquisition. So you've acquired this data set. And how did you acquire it? You used PD, which is pandas dot read CSV. So that's the keyword. You use this dot read CSV.
Bella,
Okay.
I'm adding you just 2 minutes. 2 minutes, please.
Okay, 2 minutes. Okay, so I'm going to have to share this notebook later on, but I'm just going to summarize what we've done, what we've learned, and have a look at what we can actually achieve from here. So we understand our data by taking the steps, right? And then we clean our data. What does cleaning mean? You want to put it in a format that would be fit to perform analysis on. So sometimes you have data which comes in as junk. So you've got people typing in wrong details, or the system is having a problem and is duplicating, like it's creating copies of your data, right? Or there's some information that are missing, right? So you want your data set to be clean. You're going to perform cleaning. So these are the cleaning operations that you can perform. And then the analysis is you want to perform some computations. You want to find out what is the average price of a house in this neighborhood, for example. You want to know, right? So what is the lowest price and what is the highest price, and other lots of analysis that you can perform. So that's where you do that. And then visualization, just like I said to you, you want to present it in a chat, right? You want to show in a bar chart, you want to show in a pie chart, you want to show in a scatter plot. There are different kinds of charts which you can use to show your data. And then you're going to, in the next session, you're going to learn a lot about statistical analysis. So that's really very important in data science. It helps you to perform a lot of operations, scientific methods. You apply them to your data to be able to predict or prescribe whatever you need to prescribe. And interpretation, very important. What does this actually mean? So all those things that you've done, what does it mean? So you have to give your data a voice, right? You interpret your results to your stakeholders. You explain to them what happened and what we're going to do from here. So that's what interpretation is about. Very importantly, you document your findings and you share them. So how do you share? You might have a tool that your company uses. For example, we have Tableau, we have Power BI, we have Looker Studio. There are lots of visualization tools or business intelligence tools that you can use to share your findings. But how important is it that you've done all of this analysis and you're not able to share it? You know, just like Heba said, you have to show them what you've done, right? So that's where sharing comes in this pipeline. So there are lots of other things that we can do, but this is just to get you started and to let you know that you can actually do it. It's not as difficult as you think. It's not as complicated. You just need to take it one step at a time. So thank you very much. I'm happy to answer all your questions, and just type them in the chat and we'll take it from there. Sorry, maybe I can just answer quickly what one of the participants has just asked the question about how do you know the right tool to use when you're performing an analysis. And that's really amazing, because I mean, if you're a beginner and then you're already thinking this way, I think that's a great start. Okay, so how do you know exactly what tools to use? So it all depends on your skill set. What tools are you very comfortable with? Or you can say an organization has requested you to do something, and there must be a tool that the organization currently uses. That's what you have to use. But if you were to do a project on your own, which there was no specific requirements of an environment, then it all depends on you. What skill set do you have? So if you wanted to do analysis, so you're thinking about a very basic tool like Excel. Okay, we all know Microsoft Excel, which always comes with your Office packages, or you have LibreOffice as well, where you can get a calculator. So that's what you need to use. That's the first starting point. Or you could use Google Sheets. So even if you don't have a prescription for Excel, you have Google Sheets, which is provided by Google. It helps you to do your analysis. So that's the first starting point for data analysis, which you don't want to use what I say, but for data science, you definitely have to do Python. But if you're talking about analysis, then Excel, Google Sheets, and LibreOffice, which is a calculator in that package. So these are all called spreadsheets. So spreadsheets are the first tool, your first point of call for analysis. So if I got the question clearly, I want to see again, how do you know what tools to use and the best ones? So it's not really about the best one, because all tools are great. Okay, so when you say best, you have to give a context to your best. So best in terms of, is it easy to learn? Is it easily available, or is it fast? So there's a context to your best. So it depends on what your context is, then you can properly answer that question. So if I haven't answered it clearly, just let me know, and then I'll give more details.